All right, let's get started on Unit 7, Video 2. This is an introduction to the law of sines. Make sure you have your Video 2 note sheet ready. I'm going to do two examples with you after we take some notes on what is the law of sines. You also are going to want to have your calculator available because we're going to do some calculations as well. So let's go ahead and start with what is the law of sines. The law of sines is used to determine the measures of missing sides and angles of an oblique triangle. An oblique triangle is a non-right triangle, so none of our angles are 90 degrees. Therefore, I'm not going to be concerned with where angle C is located and whether or not there's a hypotenuse because it's not a right triangle. It doesn't share those qualities, those properties. So these are the different situations that will be presented to us throughout the chapter. So given a certain triangle, we're going to be looking for all of the sides and all of the angles. I'm going to show you this on our examples. However, in some cases, I'm going to be giving you one side and two angles. That's what's going to be known to you. Your job is to find the other two sides and the missing angle. So we would use, in this case, or the situation would be set up as a side angle angle or an angle side angle, where one side and two angles are given. Here's where we're going to use the law of sines. This is explained in this video. Another situation are two sides and an angle that's not between them. Okay, so then we would have two sides and an angle that is not between them, something you didn't actually work with and you were not even allowed to address when you were in your geometry class. But this is what we're going to talk about in video 3. The next two situations, two sides and the angle between them is known. So two sides and the angle between them is known. And three sides are known, so side, side, side. And these are using the law of cosines, which you'll find in video 4. So no need to ask on the comments whether or not there's a law of cosines, because there's a law of cosines. So for this lesson, we will only address this situation. One side and two angles are known. So here we are working with one side and two angles, or two angles with the side in between them. So that's really just for you to decide which law to use. Nothing more than that. So side angle angle or an angle side angle. So what is the law of sines that I'm speaking of? The law of sines is derived for you in the book if you wanted to read through it on page 283 and 284. It's not a very long explanation, but it is given there for you. But here is the blanket, here's the law of sines. The ratio of the side over the sine of the angle is equal in all respects here. So little a over the sine of a is equal to little b over the sine of angle b is equal to little c over the sine of little c. These can be broken apart where I'm only using two of them at a time. So it doesn't matter as long as you're sticking with the side and the angle that is associated with it. In other words, I can break this apart and just say the sine of angle A over the sine of angle A is equal to C over the sine of angle C. Or maybe I only wanted to use B and C, or maybe I only wanted to use A and B. All of these can be broken down. The fact is you have to know that they are all equivalent and they all must be equal. So let's try an example. This example can be found on page 189. It's number 5 in the textbook. So you can always check your answers at the back of the book or reference it later on. So if I label all my sides here and all my angles, that this would be side A, this would be side B, and this would be side C. So if I start by looking at this, I have an angle with the side in between them. Two angles and the side in between them. So that's appropriate for this particular lesson, the law of sines. Next, I want to write down what all of my measurements are so I can determine which ones I have to find. Angle A is 37 degrees, angle B is 48 degrees, angle C I don't know. Side A I don't know, side B I don't know, and little c I do know is 18 meters. We don't have to use any special trick to find angle C. We know that the sum of the angles in a triangle is 180 degrees. So knowing that, I can subtract the other two known angle measures to find the missing angle measure. So 180 minus 37 minus 48 will lead me to angle C, 95 degrees. Then I can go ahead and I can set up any ratio that I want to. So let's say I want to find angle B. So I'm going to use little b, I said angle B, I meant side B. Little b over the sine of 48 degrees will equal 18, which is little c, over the sine of 95 degrees. I'm going to use cross multiplication to do this. Make sure you're entering and closing your parentheses appropriately. So I'm typing into my calculator 18 times the sine of 48, and then I will divide by the sine of 95. 18 times the sine of 48 divided by the sine of 95 degrees. That tells me, and let's stick to our two decimal places, that my measurement for side B is 13.43 meters. I'm going to repeat this process using my known fraction here of 18 over the sine of 95, and I'm going to do this for little a. So now I have the sine of 37. The reason I'm repeating the one that's known and permanent is because I did rounding, and so therefore I would have a rounding error. You will get marked off if you have a rounding error, so be sure to use the most concrete knowledge you have, and that was everything we know about side C and angle C. So I'm going to repeat this process where I'm going to have 18 times the sine of 37 divided by the sine of 95. 18 times the sine of 37 divided by the sine of 95. And here I come up with 10.87 meters. And that is how I'm going to use my law of sines. Let's try one more example together. In this example on page 289, number 9, I did not have a picture. I do have two angle measures and a side, and let's go ahead and take a look at drawing this triangle to see where everything is placed. Doesn't matter what the shape of your triangle is. I've got angle A, B, and angle C. Angle A is labeled at 68.41 degrees. Angle B is 54.23 degrees. And little a, which is across from angle A, is 12.75. So in this case, I have angle, angle, and I do not have a side that falls between them. So it's angle, angle, side, or side, angle, angle. Regardless, I'm going to write down the information I have. I like to make this just kind of square so that I can locate it all easily. A, little b, and little c. So angle A is 68.41, angle B is 54.23, angle C I can calculate using the angle sum theorem, which you do not have to show work for. So 180 minus 68.41 minus 54.23. Again, you do not have to show work for that. This is 57.36. That's a geometry skill I'm assuming you have. And then I know that I have side A, which is 12.75 feet. So let's go ahead and set up my law of sines in order to find angle or side B and side C. So I'm going to use the one I know the most about as my base one. So I have 12.75 divided by the sine of 68.41 will equal little b over the sine of 54.23. And 12.75 over the sine of 68.41 will equal little c over the sine of 57.36. Using cross multiplication, I will find both measurements. Go ahead and pause the video, come back, and check to see that you got the same values that I did. For little b, I got approximately 11.13 feet, and for little c, I got 11.55 feet. All right. There is an example 3 on your worksheet, and I'd like you to try that on your own. But before you do so, I just want to recap what is the law of sines and in what cases are we going to use the law of sines. The law of sines is that the ratio from the side measure to the sine of that angle opposite the side, these ratios are equivalent. You need to know this formula by heart. It's a simple one to remember, and remember that you can use it in just pieces. You don't have to have all 3 in order to find this. In what cases will we use the law of sines? There are 2 cases in which we will use it. The first case is when I have one side and 2 angles. We talked about both of these situations as side angle angle and angle side angle in this video. In video 3, you'll find out when we have 2 sides and an angle not between. And that one will look like this, and we will use that in video 3. Go ahead and try example 3 and come to class with questions.